Hi everyone, my name is Chase. I'm a application engineer here at nTopology, and today I'm just going to do a very quick nTop live on how to package up a workflow to create your own custom workflows, and also how to implement your own error check-in in those workflows, so when you share them with peers or coworkers and they input a undesirable input, it can pass either a warning or actually halt the completion of the block altogether. So recently a customer approached me and was wondering if we had an ellipsoid function, which we don't, but I generated this function for them. So for this video I'm going to generate a similar approach for generating a ellipsoid. So to start off we have to generate the ellipsoid in the first place, and to do this we are going to work with a unit sphere, and we are going to take advantage of our remap field block, and we're actually going to remap our sphere in order to take to generate the desired ellipsoid. So here I like to play around with some of the inputs immediately, and you'll notice if I multiply the y coordinate by 2 and I keep y and z the same, what it gives us is essentially that unit sphere, but our radius is now half the desired radius in the x direction. You can see using the ruler at the bottom here, it's only about 0.5 millimeters in the x radius, and then the other diameters, and then the other diameter stayed constant at about 1 millimeter, or precisely 1 millimeter. So we notice this is essentially our stretch factor, and because we're working with a unit sphere, whatever we implement as that compression or stretch factor is going to give us our desired radius. So in this case we can replace the x coordinate with x divided by the desired x diameter. So I will do that very quickly, and then we're going to repeat that for y as well, and z. So y, and we're going to divide now by the y diameter, fix some spelling mistakes, and then lastly we are going to divide z by our z diameter. Now you'll notice if I put 1 in here for all of our inputs, we're just going to get that unit sphere again, not stretched in any direction. Now, however, if I enter a 2 for the y, we're going to notice in the y direction, we're going to get a sphere with the radius, or with a diameter of 2, and then our other diameter is going to remain constant with 1. And now we can play around, and we've essentially generated this ellipsoid function that provides an ellipsoid based on our desired diameters in the x, y, and z direction. So fairly simple. We've generated this function. Now we want to package up, so I could either share it with a potential customer, or you could pass it around your organization or with your peers or coworkers. So what we're going to do is package it up by selecting our desired inputs. In this case it's just the x diameter, y diameter, and the z diameter, and our desired output is going to be dragged to the bottom here, which is the ellipsoid. I'm going to go ahead and name this function, so we're going to name it ellipsoid, and maybe add a description like this block generates an ellipsoid. And we're going to save this file. In this case we'll just save it as ellipsoid. Now what you'll notice is if I open up a new file and I import, again this was using import or file import instead of open, and I import that file that I just saved, you'll notice our ellipsoid auto-populates with the values that we left in here. Now this block is essentially in my new program, and I can use it as any other block in nTop and adjust the desired diameters appropriately. However, let's say for now there's no error check-in involved in this, so we may not want the user to implement, let's say, a negative number in one of the diameters, in which case we want to freeze the block, and we don't want to run it with a negative diameter, obviously. So what we can do is we can go back to our original custom block here, and we can use the validate block. What the validate block is going to let you to do is pass an error through that compound block if a certain condition is met. So in this case, our condition is going to be we want all of the x, y, and z diameters to be greater than 0. So in this case, I'm going to take a greater than block. And then because we don't care if all the diameters are negative, 2 of the diameters are negative, or 1 of the diameters are negative, either way we want to pass in error if any of the input diameters are negative. We're going to do a little bit of a trick, and we're just going to take the minimum of all 3 inputs. And what this is going to let us do is essentially just check the minimum based on 0, and if the smallest one is lower than 0, we're going to pass it in error. So we're going to make a scalar list, and then we are going to just change these to scalar for now, as we don't need field inputs for making a simple ellipsoid. And then we're going to make this list of 3 objects and pass it the x diameter, the y diameter, and the z diameter. And you'll see automatically the propagated value is 1, which is the smallest of all 3, but in this case we're concerned with if it's -2, it's going to pick up that negative number. Then we're going to pass that in an operand A, and we'll check that against 0. And obviously we'll see here that there is no error. False, there is an error. If they're all greater than 0, we're going to get true. And we're going to propagate the condition with this validate block that we set up that will essentially push an error if this condition is false. So in that case, one of the input diameters would be less than 0. We're going to select our message that we want to propagate. So in this case, we'll say, please enter positive diameters only. And then we can choose here whether we want an warning or an error. In this case, the difference being an error won't actually run the block, a warning will run the block, but give the user a warning that something might go wrong. In this case, we want to freeze the block altogether, and we'll select the error. And then just having this block in this workflow is enough. So it's going to run that validate block when we re-import it into our new file and we use the desired input. So I'm just going to resave this. So I'm going to go File, Save. Going to reopen that block we have here, and I'm just going to re-import this compound block. And what you'll notice is nothing has changed, except for now, if I enter a -2, you'll see the block doesn't run, and if we click our error, it'll say please enter positive diameters only, which is exactly what we want it to do. If I re-enter a radius, we can run like that. So this allows you to kind of pass some knowledge. You know, if you generate a custom workflow, but there are certain parameters that you want to be met, maybe something isn't printable, or it gives you freedom to pass information along with custom workflows to your coworkers, peers, or in our case, customers. So all of these blocks will be available in this nTop Live, and I encourage you to check them out, see how they're generated, practice a couple of your own validations on your own custom workflows, and feel free to reach out with any questions. More than happy to lend a hand, or if you're new to nTop, to give a demonstration on what we can do and what type of workflows we can work with you on building. So awesome. Thank you very much for listening, and have a good day.